Hi guys, I'm Yanshika.
Today, we're here to teach you some do's and don'ts of the AP Statistics test and class.
Let's get started.
Tip number 1, don't forget to charge your calculator.
You will not be able to do a majority of the equations, confidence intervals, and hypothesis tests unless your brain is a computer.
Hey, Vanshika, are you ready for the stats test?
Yeah, I even brought my calculator. Let me get it out. Oh no, how am I gonna do this without a calculator? I guess I have to fake my way through this test.
Hey, Vanshika, how'd you do on the test? I got a 70. My parents will be so proud of me.
I got a 22%. I wish I charged my calculator last night like any good AP Stats student. Tip number 2, do not put decimals into your calculator for the 2 proportion Z test.
Okay, for my population size, I got a 23.8 and a 17.1. I'm gonna plug that into my calculator and just see what happens. Hopefully I get a 5 on this AP test. What? Oh no, what am I going to do? Oh, this is awful. Well,
Tip number 3, do not forget phantoms.
Phantoms is 8 steps. They're really hard to remember without prior preparation. So we're gonna help you go through them one by one.
The first step is P, parameters. Define the context of the problem and the variables that are being used.
The second step is H, hypotheses. Don't forget to state your null and alternative, or H0 and HA, hypotheses before beginning the problem. Pro tip, H0 will always have an equal to, and HA will have everything else besides an equal to.
The third step is A, assumptions, otherwise known as conditions. Each kind of hypothesis test will have a different type of condition, such as large count or 10%. However, each problem will have a condition that the sample must be random.
The fourth step is N, to name the test that you're going to be using. This will depend on the context and scenario given in the problem. Examples of this are the 2 proportion Z test or the 1 sample T test.
The fifth step is T, test statistic. Test statistic is also known as Z-score, and it can be found using a simple equation.
The sixth step is O, obtain a p-value. This is done by putting the appropriate test into your calculator and plugging in the correct values into the right places. Make sure to do this with care and write down each step you're putting into your calculator on your paper. Also, make sure to draw a normal distribution curve for extra points.
The seventh step is M, to make a decision. Always use a significance level of 0.05. If your p-value is smaller than 0.05, then you reject H0. If it's bigger, you fail to reject H0.
The eighth and last step is to summarize in context. State whether or not HA has convincing evidence for it to be true, based on your numbers that you found and the words given in the problem.
Now let's see a scenario of this being used.
All right, we're going to be going over an example problem. The context is up here. So step 1, given a population of graduate students, we are trying to find the true proportion of students looking for on-campus housing. That's step 1. Step 2 will be to make your hypotheses. So H0 is P equals 0.1, which is given in the problem. And then the alternative, HA, will be P is greater than 0.1, also stated in the problem. Next, we have to check our conditions. Random is stated. Independent, you have to do the rule where 481 has to be smaller than 1/10 of all grad students at a large university, so that's good. And then for normal, you have to do the large counts test, which is there and there. Those are both also checked, so we're good to proceed. We will be using a 1 proportion Z test at a significance level of 0.05, which is good to note, so that the proctors can know which test you're using. For the p-hat, you're going to be doing 62 over 481, which gives you 0.128. And then you're going to be using that in the Z-score, which is right here, and that gives you 2.046. So then you find the p-value using normal CDF. Make sure to note that the mean will always be 0 and the standard deviation will be 1. So that gives you 0.0203. And that is obviously smaller than 0.05, so we reject H0. So then we have to state the problem in context. So assuming H0 is true, the probability of getting a value from the sample as extreme as one observed is 0.0203. This is smaller than alpha, so we do not have convincing evidence that the findings are statistically significant at the level, so we recommend that the office should consider increasing the available housing.